Hi, this is Randal Schwartz, host of FLOSS Weekly. This week, Jonathan Bennett joins me. We're going to be talking about Hackaday, which is a great publication for learning about hardware and software hacks. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
This is FLOSS Weekly with Randal Schwartz and Jonathan Bennett. Episode 541, recorded on August 7th, 2019. Hackaday. This episode of FLOSS Weekly is brought to you by Command Line Heroes, the original podcast from Red Hat. It's back for its third season, and this time it's all about the epic history of programming languages. Episode 4 tells the origins and evolution of Perl. Go to redhat.com/heroes or listen and subscribe wherever you get your podcasts. And by CacheFly. Give your users the seamless online experience they want. Power your site or app with CacheFly CDN and be 30% faster than the competition. Learn more at twit.cachefly.com. Time for FLOSS Weekly, the show about free, libre, open source software. I am your host, Randal Schwartz, Merlin at Stonehenge.com, bringing you each week, or as often as I can, the movers, the shakers, the big projects, the little projects you may be using every day and not aware of it, projects you might want to download right after this show and play with. Today's probably not going to be one of those. Today is more about an information show. But joining me once again is my lovely and talented co-host, Jonathan Bennett. Jonathan, welcome back.
Hey, Randall, it's good to be here once again. You know, if we keep this up like we've done the last 3 weeks, I will eventually pass you in show count.
We're looking at that. You know, and the problem, of course, was, okay, 2 weeks ago I was sick. Last week I had no internet. And you guys covered for me, and I appreciate that. That is so cool that you guys can actually take over the show when I am not available, not around. This week, I am on the big chair, though. I am on the host chair. I am in the, as we call it, the Tijuana kitchen set, which once again has refrigerator magnets. And one of the magnets was moved from all the previous shows. And so, again, we haven't had anybody actually guess the actual thing that's been moved. But please feel free to either text me or whatever you want to do that. So we are going to have an interesting show today where, Jonathan, you are both a co-host for me, thank you, and sort of a guest, actually, in some sense. Do you want to describe what Hackaday is about?
Sure. So, and Mike, of course, will be able to do this better than I can, but Hackaday is a website. It's kind of an aggregation for stories of clever hacks, silly hacks, strange things that people have done that are creative. And it's all about kind of using, well, it started out at least, using hardware and things in new and novel ways that they probably weren't intended for. But, you know, in the years since it started, we've kind of branched out. And so we cover news stories. We do some editorials. For example, I've got a weekly column on Hackaday where I write about computer security and the security news for the week. And so it's kind of a catch-all for news and stories and information that people like probably you and me would find really, really interesting. And a big part of that happens to be open source software and open source hardware. And so I thought it just seems like a great fit for us to talk about it and maybe talk about some of the history of it.
And how do you describe Mike Stitch as his relationship to the publication?
Mike is one of the editors. I don't remember if he is the head editor. I don't remember exactly what his title is, but he is one of the two guys that I would describe as my boss for the work I do over there.
Well, Mike will be coming on in just a moment, but before we do that, I actually have an important message I'm going to be delivering here, because this episode of FLOSS Weekly is brought to you by Command Line Heroes, the original podcast from Red Hat. So in 1999, Perl, I've heard of Perl. Perl was a programming language rising to prominence in the world of web development. Fast forward to 2018, Perl makes a list of languages in danger of going extinct. Command Line Heroes is back for its third season. It's all about programming languages, from C to JavaScript to Ruby to Go. The podcast dives into the origin stories of some of the most prominent languages around. Episode 4 takes a deep dive into the world of Perl, exploring how it became a crucial player in the early days of web development, and then goes beyond the hyperbole to show why it continues to stay with us, which becomes obvious with a little history and a look at the bigger picture. Command Line Heroes, an original podcast from Red Hat, is all about the people who transform tech from the command line up. So to listen and subscribe, head on over to the podcast platform of your choice or visit redhat.com/heroes. That's redhat.com/heroes. There you'll find full episodes as well as bonus content, and you can even test your skills on the Command Line Bash arcade game. We appreciate redhat.com/heroes for their support of FLOSS Weekly. Let's go ahead and bring on Mike. Mike, welcome to the show.
Well, thank you. It's so nice to be here. I appreciate you having me on as a guest.
Yes, and so tell us what is this about? What do what is the show about?
Well, so I'm glad that you asked me on today. I think that Hackaday represents a big movement within open source and open hardware to kind of share and show off all the things that are happening in engineering. And as Jonathan mentioned before, a big part of what we cover is items being used in unusual ways. And so you're going to see people that are taking software and using it on platforms that wasn't intended to be used. You're going to see people that are taking hardware, chips, that sort of thing, and putting them into devices that didn't expect to get any more technology than they were already produced with. And you're going to see things that basically come to life in front of your eyes and delight you.
And how did this get started?
So we're actually celebrating 15 years in September. The site was started by Phil Terone back in 2004, and it started as just one article per day, and that's where the name come from, Hackaday. But it became really popular. If you think about what has happened in the hardware world, I mean, back in 2004, we didn't have smartphones. You didn't have devices in your house that would connect to a network. In fact, I would say the majority of households in 2004 didn't have Wi-Fi yet because there was no devices to put on them. And so over the years, you saw a large number of people trying to build and produce their own personal electronics. And the unique thing about Hackaday is, unlike companies that are making products and want to sell them, everyone that was building something and was involved in the Hackaday community was showing it off. Like, look, here, I found this chip that lets me put this on Ethernet, and here's how I hooked that chip up. And then someone took that design and said, I made this even better. You can do it with half the hardware that you used to be able to do it. And fast forward until now, we have people that are writing apps for smartphones, that are building clusters out of Raspberry Pis and exploring every frontier that is available to them. It's really a great time to be learning about hardware and to be, tinkering under the hood.
So is this related to the maker community that O'Reilly's been promoting?
Yeah, I would say we have crossover into the maker community. One of the things that I think about when it comes to the difference between makers and hackers is makers are usually following some kind of path or some kind of instruction set that gets them to the end that they're seeking. Hackers are kind of under the hood working on something and maybe don't even have an end goal in mind. They're just trying to see what they can do for the purpose of doing it, and it serves to inspire other people in their own workshops, garages, basements, that sort of thing.
So this is more like people just poking at things, trying to make things do different what they had not expected them to do.
Yeah, I would say so. One of the most interesting things that's going on right now are people working on FPGAs. These are field programmable gate arrays. Think of it like a microcontroller, except for there's no computer inside of this thing yet. You write the code that actually puts hardware building blocks together and forms a microcontroller or an audio codec or basically anything you want inside of there. Up until maybe 2 years ago, all the tools that you would use for that complex device were completely locked up with the vendors. So it was, Xilinx and Altera had their own, they call them synthesis tool chains. But about 2 years ago, Yosis came out, and it allowed you to write your own bit streams with using open source tools. And that means that you can do things like automate your process. You never had the hooks to do that before, but it also means that you could extend it. And about 2 weeks ago, I saw a really amazing project where someone had taken this tool chain meant for FPGAs and kind of given it a detour for their own purpose. They put in the old 7400 series logic, which you would be familiar with from the 70s and 80s.
I am, yes.
So you can write some Verilog, and you can click the button on Yosis and have it spit out the circuit diagram for building the thing you designed out of 7400 series logic, something that would have been completely impossible under the closed source tools.
My favorite device of that era was the Hex Inverter, because I always thought it would be great if you were a witch.
Have you tried your hand at FPGAs, Randal?
No, I haven't. I'm amazed by them, though. I'm really amazed by them because they basically can. They're essentially a breadboard on a chip. You can make whatever you want from those things. I'm not much of a hardware guy. I mean, I'm a software guy. If I can't telnet into it, it's not a machine. Or no, sorry, SSH to do it now. I used to say telnet into it, but that dates me. I think more than dates me, it carbon dates me. So it's been a while. So. In your publication, so you've got like daily articles that are showing up in Hackaday, and maybe even more than once a day. What are the kinds of what's the scope of what we're going to be seeing there?
Yeah, so it's certainly more than once a day. That's kind of what we started with 15 years ago, but now we're up to about 300 articles per month, and you're going to find them for anywhere from about 30 to 35 authors each month, depending on who's working on that sort of thing. Like Jonathan said, he does a weekly roundup of all the computer security. We're not a computer security focused site, but this community is something that people look to for advice. All your friends and neighbors come to you and say, hey, what's going on? I heard this thing in the news. And so it's nice to keep people apprised of that. You're going to see FPGA designs, you're going to see microcontroller designs, you're going to see art installations where people have done something interesting. There's a lot of CNC projects. So we covered the rise to prominence of consumer 3D printing, starting with the RepRap community and all the way up to the consumer grade at this point. A few weeks ago, I saw someone working on a scanning electron microscope build that will then be used for electron beam deposition. Is it electron beam melting, EBM, which is basically like a metal 3D printer, but on the very, very small scale. And this person's just doing it in their hackerspace in, I think it's in Czech Republic, but then showing it off so that we can all see and follow along, and even put up the plans for the high voltage circuit board that drives that. So if you need an SEM in your basement and you want to build it yourself, you go to Hackaday.io and check that project out.
Hey, Mike, it's good to see you. Hackaday, it started out very simply. It's changed hands a couple of times, hasn't it? Can you give us just a quick rundown of like the history of we talked a little bit about where it started, but how it ended up being part of Supply Frame, and what's the history of that?
Yeah, so it actually was started off as part of Weblogs Incorporated, and there were a few others that were in there that you would be familiar with. The one that comes to mind is Engadget. I don't have the rest in front of me. I think there were 25 different blogs at the time, and that ended up being sold off to AOL Time Warner, but they held back Hackaday because we wrote about TiVo hacking, and I think that was seen as a conflict of interest at the time. That company held Hackaday until 2013, and then sold us to Supply Frame Incorporated, and we've had a really great time with Supply Frame as our parent company for the last 6 years now. Supply Frame has given us a huge amount of support in budget and reaching out to strategic partners, and has allowed us to do things like host the Hackaday Super Conference, which is November 15th, 16th, and 17th in Pasadena this year. We have about 400 or 500 people come to that conference, and it's kind of the pulse of the hardware world. I like to call it the ultimate hardware conference. We also have been hosting the Hackaday Prize every year for the last 5 years. This is our global engineering initiative where we ask people to build a piece of hardware depending on the theme for each year. This year, we're looking at product development. So a lot of times companies are developing a piece of hardware for sale, and you never get to see what goes into developing the hardware itself, what goes into market research, and figuring out if it works for the users, because it's all proprietary and locked up. And so this is a way that we can kind of show that off. What makes a product successful beyond the actual hardware on your bench? That is still open, actually, for anyone that wants to enter. The top prize is $125,000. We have 5 other category prizes for $10,000 each, and 5 more honorable mentions for $5,000 each. So there's a lot available. Let's see. That one is prize.supplyframe.com. If you want to go look at that, and it's open until August 25th.
We do have a live chat room and take questions from time to time. And Amiga Dave-Pi, which is just a great username because of reasons, wants to know what's his expertise. Mike, what's your background? What is your expertise that you bring to Hackaday?
So I am a microcontroller enthusiast. I started off building beam robots when I was just out of graduate school and really loved it, but there's only so much you can do. They're kind of like dumb robots. They react to things like light or like a whisker sensor being tripped when you bump into something. And so I started looking around for how to make them more interesting, and found out about microcontrollers. And at the time, if you've heard of Arduino, which is a very popular microcontroller platform, they weren't around yet. This was before that time. And so I got a basic Stamp 2. Randal, are you familiar with those? Sorry to put you on the spot.
Sorry. My mic muted. Would you microcontroller what?
The basic Stamp 2 controller boards. Do you remember those from Parallax
I'm not
back in the day?
I'm not a hardware guy. I'm not a hardware guy. I don't know that stuff. I'm a software guy. I'm a software guy.
So they were totally fun. It was like a system on a module. So it was a little circuit board, kind of the shape of a chip, but it had a bunch of different circuits on it, and you could burn code onto it. And once you did, it didn't need a computer anymore, and it could just run. These days, that doesn't sound like much because microcontrollers are everywhere. But back then, the expense of compilers for that and programmers for that were outside of what an individual could do. So the basic Stamp really changed things. And I was just amazed that I could write a program and have it run somewhere other than my computer. And I went down the rabbit hole of adopting AVR microcontrollers from Atmel that are really great RISC instruction set. You could write them in C or in assembler. And then, of course, we saw just a flood of things come after that. We saw Arduino built up around the AVR microcontrollers. We saw the Embed platform come out, which oftentimes allowed you to use just USB to program the board. And more recently, I've been playing with STM32 microcontrollers and the ESP32, which is a really amazing, for a few bucks, I don't know, $10 or something like that. You've got a dual core 32-bit processor that is connected to Wi-Fi.
You know, thinking back through this and where I first started hardware hacking, I'm pretty sure, I'm gonna talk about how young I am, I suppose. I'm pretty sure my first Internet of Things hack was inspired by Hackaday, and it was connecting an Arduino to a computer over USB and getting some glue code in there so that the computer could flip a relay to turn lights on and off. And that was quite a few years ago. It would have been when Hackaday was in its early years, I think. But you know, that's where I started with the Arduino, and it was a breakthrough. It was an entirely new world that you had code that works on the computer, but you could then take that code and change things in the real world with it. And that's really kind of that's the thing about microcontrollers. That's the thing about making hardware open, is that you can suddenly do these things that before were just, you know, almost sci-fi. And then a place like Hackaday comes along, or you find your first story about open hardware, people doing this sort of things, and then you realize that for just a few bucks, I can get an Arduino and do some of these too. It's magical.
Yeah, there are a few really interesting kind of validation points that I like to think about through Hackaday. I mean, really, Hackaday is like a common link in the connective brain for the hardware world. And so if you look back about, let's say 5 or 6 years, everybody wanted to have their Internet of Things device. They wanted to have something that connected to a network, and you could do it with Ethernet, but really, who wants to do wired things? So Wi-Fi was the way to go. And, people were taking cheap routers like I think D-Link routers and opening them up and like soldering on to the serial port. And it totally worked, but it's kind of wonky. And then all of a sudden, these rumblings came out, and we covered a ton of it on Hackaday, of this chip that someone had found that they could get for $3 that got you on the internet, got you on Wi-Fi, and using just like AT commands. So it was like old school 80s modem commands that you sent to this thing, but it had, the sci-fi futuristic wireless internet. But you could only get the data sheets in Chinese, and even then it was hard to find them. And there was this huge group effort to translate those and figure out how to use them. And it grew into this huge company. I think this is a really good example of what Hackaday covers, because this chip was never meant for individuals to use or discover. It was meant for companies that were making connected devices in the thousands. And this thirst for the new technology and cutting edge really changed the way that company, the company's called Espressive. It changed the way that they're doing business, and I think for the better.
I kind of chuckle when you say nobody wants to run Ethernet, because I'm the guy that ran Ethernet all through my house and hung a bunch of Raspberry Pis off of it. Which every time I write about it, somebody in the comments goes, "Man, you should have used ESPs." Like, I know.
No, I think for you, you've got the exact right application, because you're putting a Raspberry Pi in every room. So it's going to need wall power. It's not going to be a portable device. But for, the Internet of Things, people want to be able to move stuff around. I mean, think of how upsetting it is when you want to sit on the sofa and use your computer and you have to go and get the power cord for it. Imagine if you had to do that every time you wanted to send an email.
Yeah, true. Let's talk about the Hackaday I/O. I don't think we've really dug into that yet. What is Hackaday I/O, and why is that a thing?
Yeah, so one of the first things that we were able to do once Supplyframe acquired Hackaday is leverage their engineering team to build up a project hosting platform for open hardware. And this was 2014 when we first launched, early, maybe first quarter. And it's really taken off like crazy since then. We have about 350,000 users and 30,000 projects on there. And it's everything from a CNC robot that will paint like Bob Ross. I was just reading that one today. To building your own 3D printers, to hardware badges that blink and do other things when you wear them to conferences. SMS, text message notifiers that'll tell you when your clothes are done in the dryer. Custom instrument clusters for your motorcycle. If you name it, you can probably find it there. And I think that's one of the best things about sharing open hardware is if you have an idea of something you want to do, you can probably find some component or some building block of that idea within someone else's open hardware project, pull that out and incorporate it into your own. And even if you don't have the skills to do that, you have the ability to find other people that you can build into your own engineering dream team and then work together collaboratively, even if you're separated by great geographic distances. I really am inspired by the ability of distributed engineering teams to get work done and produce, hardware and software that everyone can benefit from.
Someone just whispered in my ear that's listening that we're talking about open source hardware. Does that turn this show into FLOSS?
I hope it does turn it into FLOSS, because you can't have open hardware without open software these days. The vast majority of things are no longer, analog electronics. You've got some kind of code running in there, and the ability to look at how people are, using Wi-Fi modules or proximity sensors, or driving commodity screens that are left over from first generation iPod touches. How they're taking single board computers like the Raspberry Pi and turning them into clusters that can do basically supercomputing tasks without needing to wait for the time on your university's supercomputer. It's not possible at all if you don't have the kind of base layer of open software that has been built up around the hardware world.
Well, it's kind of interesting between FPGAs and microcode, things like that. We've actually kind of blurred the line between what is hardware and what is software. And open source applies to all of it.
Yeah, it's never been easier to build things. It used to be, you would have to start from the ground up. You would hook together your circuits, and then you would go and paw through data sheets that are hundreds or even thousands of pages long and start with your base layer of, low-level drivers that give you hooks and do some hardware abstraction. And at this point, a lot of those problems have been solved. We talked about the Arduino platform, which is a simple, I think it's a Java-based IDE that allows you to pull in other people's libraries and basically not even know how the hardware is working. There's a new development in the last few years called CircuitPython, which Adafruit has done a ton of work on libraries to make that happen. So you can pick up a small microcontroller board for a few dollars, and if you already know Java, you can get in there and turn lights on and off. And it's not likely that you're going to just take your Arduino project and end up turning around and selling it. Some people do that, but I think it becomes the gateway drug. And so if you're already used to how software works, and you think to yourself, you know what I need a little bobble. I need a little cog that I'm going to build myself. You can get these boards, and you can get sensors that are on breakout boards that are very easy to put together without any soldering or anything like that. You can do it on your couch or on your desk and prove the concept. And at that point, look at it and say, I think I can do this. I'm going to take the plunge and take all of these development boards and put them into one custom designed circuit board, 3D print an enclosure for this, and go and try to prove my market and start an open hardware business. Yes,
one of my favorite things that happen on Hackaday are the times when one of us writes an article and somebody in the comments says, "Hey, I've done something similar to that," and describes a little bit about it. And then we go to him and we say, "Do you have this written up somewhere? You should really write this up, maybe on Hackaday.io." And a couple of weeks later, they've written up this nice blog post about it, and we then go and link to it and say, "Hey, everybody needs to know about this." It's just a neat series of events when that happens.
Yeah, it's really wild how that happens. I hear people say this all the time, like they talk about our project. I'm like, I'd love to read about it. They're like, I didn't think anybody would be interested. And people are just like self-eliminating on that. And really what we do around here, it's like standing around in the garage with your friends and someone pulls out a blinky piece of hardware and you all go, ooh, what is that? And then they tell you. And so we want to hear those stories. I think the other thing to think about is open software and open hardware allow you to have a curriculum vitae online. So whether you're trying to be a contractor or start your own business or get a job or just have fun and work with other people on a project, the best way to do it is to get out there and write about your project, because it shows your passion. It shows your domain knowledge. It shows that, I think these days, employers want you to be able to speak very well about the things that you're working on. And so everyone should be writing about what they're doing on the side and showing what they're learning. Selfishly, I tell people, go document your project on Hackaday.io, because when you pull it out 2 years from now and you want to work on it again, you're not going to remember any of the traps that you left for yourself the first time around.
Oh, there's a famous, I think he calls them cones, but pithy sayings for programmers, basically, that ESR maintains. And one of them is the rockstar programmer disdained comments, and the master came to him, comments in his code, and the master comes to him and says, no, there's one person that will always forget how the code works, and you need to document it for him. And the rockstar programmer is like, who in the world would that be? What kind of idiot will always forget what it's future you?
Oh, yeah. Well, so we do a hardware badge, a piece of custom electronics that is the conference badge for the Hackaday Super Conference every year. And I think it was either last year or 2 years ago, a few nights before the conference started, I remembered I had a game of Snake that I had written several years back. And I thought, you know what? I'm just going to port that. It's on GitHub, no problem. And I ported it over and I started playing it, and it had bugs in it. And all of a sudden it slowly dawned on me. I'm like, yeah, I remember these bugs that, like, sometimes the fruit that the snake would eat would generate underneath the tail of the snake. And because of that, you wouldn't see it because it had drawn the snake there already. So yeah, boy, lay traps for yourself and enjoy the fruits of that. That actually brings to mind, so the Hackaday Super Conference badge this year is FPGA based, which is super exciting, and we're planning to build up workshops around that, so anybody that hasn't programmed those FPGAs before can go and try it out themselves. But it'll also be running a RISC-V core. I'm not sure if you talked about RISC-V much on the show, but it's, to me, super exciting because microcontroller designs are the closest of closed source things, and all of a sudden the RISC-V Foundation came out with this open microcontroller design that you can run on an FPGA. You can build up your own peripherals for it. So if you need some kind of audio out or special video, or you need to read very quickly from a sensor, you can build all that up around it. If you end up having a very successful design and a lot of people want it, you can prove it on the FPGA with these open cores, and then decide you're going to take the very expensive leap of actually rolling your own silicon from there.
So I can't let Jonathan have all the interesting questions, so I'm going to take over for a bit here. But before we do that, I have a very important message, because this episode of FLOSS Weekly is brought to you by CashFly. Give your users the seamless online experience they want. Power your site or app with CashFly CDN and be 30% faster than the competition. No matter what industry your business is in, if your website is directly tied to company revenue, give your customers the fast downloads they need with CashFly. CashFly CDN delivers rich media content up to 10 times faster than the traditional delivery methods and up to 30% faster than other major CDNs. Backed by a 100% SLA, CashFly guarantees the best user experience for all your customers, no matter where they are or what device they're on. Join the thousands of others who trust CashFly's reliable network, including LG, Microsoft, Adobe, and Ars Technica. Leo says we've been hosting all of our podcasts, audio and video, on CashFly for nearly a decade. Every month, our viewers and listeners download petabytes of data fast and flawlessly that TWiT would not exist without CashFly. Say goodbye to logging in multiple times a week, or worse, even daily, trying to track your CDN usage. There's no billing spikes. Get a custom plan tailored to your CDN based on yearly usage trends. On average, customers who switch to CashFly save more than 20%. Just imagine what you could do with that 20% and your time. And just for TWiT listeners, CashFly is giving away a complimentary, detailed analysis of your current CDN bill and usage trends. See if you're overpaying 20% or more for your CDN. Learn more at twit.cashfly.com. That's twit.cashfly.com. And we thank CashFly for their support of FLOSS Weekly. So I'm sort of curious about now what's actually happened in the hardware realm over the last, say, 10 years that would make it easier. I mean, like I said, I played with like 7400 circuit boards and things like that back when I was younger. What's changed in terms of like FPGAs and things like that to make it easier to do open hardware?
Yeah, so I think that if you look at the success of open source software, one of the biggest parts of it is basically anybody can clone the repo and run it on their machine and push back their changes for the common good. Open hardware has a few more challenges there because you generally need to build the piece of hardware or somehow acquire the piece of hardware in order to work on it at all. And that was very difficult 10 years ago. It's become a lot easier now. You mentioned before the maker movement. And so you can think of the maker movement as individuals or small groups of people that want to do the things that very large and expensive hardware-based companies were doing in the past. And so the entire industry was kind of optimized for that larger company thing. They didn't really want to talk to individuals and help them out with data sheets or small quantity of chips. And that's the biggest thing that has changed is you can actually go to a distributor like DigiKey or Mauser or Element 14 and buy single chips of just about anything. And for the vast majority of them, get the data sheets, the instruction manuals that you need to run them. But still, if you're just, you would have to know how to find those chips, and you would have to know what they do and how to hook them up to other things. And it's a pretty steep barrier for entry. So I think the other element that has come into play is the availability of modules and libraries. And so instead of going and looking up some bizarre part number, LSM 3715, what is that? I just made that up. But I mean, that's how what they sound like. You might say, I need something that can measure distance. And so you start looking around, and there's enough people that have shared their open hardware projects that you find out here's a distance sensor. It operates on infrared. And, oh, look, here is a company, SparkFun, that has put it on a little circuit board, and you just need to have 5 volts and ground and a couple of data lines. Okay, what protocol are those data lines? Oh, hey, there's a library for that, open source library. And you can begin to piece these things together. And once you do that, like, can I get the chip to turn on and give me some data? Then it's a trivial matter to actually put it in your project and start doing the software glue that connects it to whatever you need.
Well, is it fair to say that it used to be that what open hardware meant was that I had a Raspberry Pi and I had some daughter board that would do some specific function, and I'd have to learn how to program that somehow, probably with some Python language or whatever. And now it's like, now you can basically embed whatever sort of microcontroller you want in there because it's all, it's like an FPGA. Is that a fair assessment of the change in the last 10 years?
Yeah, so I think the newest thing happening right now is the availability of FPGAs to be used by individuals. So the changes that we've seen over the last 10 years on being able to build up your circuits, or being able to start with a single board computer like the Raspberry Pi and do something like build a time-lapse camera out of it, that's become very accessible. FPGAs they look just like a chip. So it's like a little black plastic package on a circuit board. And you might have a project where you want a time-lapse camera that can actually do some image processing on it. So let's say you wanted to be able to do like motion detection on some camera. You could use a Raspberry Pi and you could use libraries to do that. But if you wanted something that was kind of commodity, you make it on one circuit board and it goes into a little case. A lot of people might reach for an FPGA these days, which would allow you to have, some kind of microcontroller core inside of it. You would write it in a computer language that you would upload to the chip, and it would build that in hardware. But then you might also have parallel processing for that image that compares, 10 frames in a row and looks for pixels that have changed on some threshold. And it would do that with a much lower power budget and much faster than running, say, a full embedded Linux system like Raspberry Pi. There's, I think it's called ICE 40 is what's coming to mind right now, which is the tool chain for writing that code to build hardware within those FPGAs that is open source. And I know it's Clifford Wolf and a bunch of other people that have done amazing work on that, actually writing software that would iteratively try and do what they call synthesis for that part, and then compare it to what the vendor tools were doing to see how close they got on it. And they basically reverse engineered a compiler for that's what synthesis is really like compiling Verilog into what the chip needs to make sure it's exactly mapping it. And the impact of that is you don't need to sign the vendor agreement for your tools. You're not locked into one company. Some people really value that, but I think the more powerful thing is it opens up FPGAs for uses that were never intended, which is what Hackaday is all about. So I mentioned before being able to use that tool to design 7400 series logic circuits where you might have it. If you think about the Apple, like the breathing LED, that was the project that someone did, was make a breathing LED based on hardware, and it used like 15 chips in it. But instead of having to go to, 4 years of engineering school to do that design, they taught themselves some Verilog and then ran it through this open source project and were able to build that circuit.
So is this all like hobbyists playing around, or are there actually commercial applications that have started using some of the stuff that people are developing?
Oh, so the highest of the most talented engineers in the world, in the hardware world, are hanging out around Hackaday and are showing off some of the things that they're doing. I'm consistently blown away, not just by the projects that we're covering, but the people that show up in the comments. And so you might be talking about some amazing piece of hardware that's just been torn down, and someone will come into the comments and say, "Oh yeah, I was on the hardware team that developed that. Ask me anything." And you'll get a ton of stuff there. But I also think that you have a responsibility in the open hardware world, that the more elite your skill becomes, the higher expectation it is that you will share those things that you learn so that others can follow in your path. We always talk about standing on the shoulders of giants, and what we have to realize is every day that goes by that we're working on these skills, we're becoming those giants, and we need to pay that forward because we all benefit from a widespread understanding of science and technology. I think universally at this point, the power of the internet and the power of our digital revolution and technology around us has been accepted and embraced by people, while at the same time, the understanding of how those things actually work has gone down. And I think that's dangerous because it then just becomes magic. People don't understand how it works, and that makes them feel like powerless. Like you hear people say, "Oh, I'm not a technology person," but they use technology in their life every day. And so Hackaday really promotes, like, you can look under the hood. You're not going to break this stuff. You can learn about this. It doesn't take a wizard to understand it. It might take a wizard to push the new boundaries, but by chipping away at it a little bit, you can gain those skills that you need.
Is this the kind of thing that would show up, say, on the space station or on like a Mars rover?
Yeah, absolutely. So are you talking about the FPGA technology?
Yes.
Yeah. So I don't know of an exact example right now off the top of my head, but the real power of these FPGAs, so field programmable is the FP in there, and that means once you make a product with an FPGA in it and you ship it to a customer, you can, through basically a firmware update, you can change the hardware that's inside of it because they are field programmable. Microcontrollers are made of, tens of thousands, hundreds of thousands of gates. They're usually NAND gates that are used to build that up. FPGAs are basically like a big box of Legos of all different kinds of gates, and the code that you write ties those gates together in a way that makes them work very similar to a microcontroller or a computer chip. And so if you find out, like, hey, there's a new codec out there, we're not using X264 anymore, we've moved on to X265, but I shipped a product without it. If you have enough gates left over in that chip, or if you want to repurpose them from some other codec, you can just push an update. And so if you look at space or going to Mars, this is really transformative because, hey, we have a rover that's been doing a science mission on Mars, and that science mission is over. What else can we do? Hey, there's this other thing, but we need to process the data in some way on the rover itself. Let's push an upgrade to the FPGA. You could see how that can be a huge benefit for hardware that you're never going to be able to send a technician out to do work on.
How do you prepare for a career in this area?
So almost everyone that goes to engineering school will do some work on an FPGA at this time. It's the same way that they'll do some work on a microcontroller, on like an embedded Linux system, on analog electronics. So everyone gets a little taste of it. But don't think, oh, I didn't go to engineering school, so I can't do this stuff. The joke is you go through engineering school, you get your degree, and you go to your job, and you realize you don't know anything you need to know to do your job. Almost everything is specialized and requires on-the-job training. So if you want to prepare yourself for a career in this, it's just like programming. Get something simple and try it out. Get one of those inexpensive CircuitPython boards and write some Python for the chip, and then decide, people are doing stuff in C instead of Python. Try and write some C for that, or get yourself a Raspberry Pi and try embedded Linux on it, and try hook up some LEDs and see if you can command them from the internet, so that every time someone likes your Twitter post, the light lights up on your desk. I think it's hard to describe how giddy and how transformative it is to see a piece of hardware change in the real world. So whether it's moving some object, like putting up a flag that's like, it says, Twitter-like, or just lighting up LEDs in the scanning pattern like they had on Knight Rider. When you realize you're the one that wrote the code and connected the boards together that made that happen, it's addictive. I call it a gateway drug because it does feel like you then need to find the next thing and climb the next mountain.
Well, I think that's like all software actually has been for me. It's like I've been doing this for 40 years now professionally, and it's always interesting seeing what the next thing is that I can do, and to keep working on things and to keep absorbing new things. Like right now, what I'm doing is absorbing Dart and Flutter, because that's like the newest, greatest edge for me to be able to do stuff for this. So you've been running Hackaday for a while. What's the most controversial post you've had?
Oh boy, there's a question I don't want to answer.
Hey, sorry, it was whispered in my ear by this other guy we've got on the chat.
It's a good question. Just because I don't want to answer it doesn't mean it's not a good question. So Hackaday believes in the free and open sharing of information and ideas. I think it's really important that we can talk about things, and it becomes a difficult question of comment moderation sometimes. Okay. I guess one of the topics that has been very controversial is like 3D printed guns, and you've seen that, kind of burn its way through the wider media. And, when that was one of the things that we do at Hackaday is look at the engineering stories that are being missed in wider media coverage. And I think with 3D printed guns, there's this, kind of hype and, panic about someone being able to make an untraceable weapon, and because it's a 3D printer, most people don't understand that technology. They assume that you get a 3D printer, order it off of eBay or something, and plug it in, and you press a button, and a gun comes out, and that's like saying, that you order a lathe off of the internet, and you press a button, and a gun comes out. So looking at those stories that have definitely a misplaced understanding of engineering in them is a big part of it, and sometimes they're controversial, and that was one of them.
Wow. Okay. Well, I can certainly understand that. That's always an issue. Is like, okay, what are we doing to enable people doing bad things? And that's not a good thing. But I totally understand that. So what's been probably the most unusual article, the most spectacular article maybe that you've published over the years?
Oh man, Jonathan, do you have a favorite on here while I try and think about this?
Oh goodness,
I'm asking
that's a difficult one, because there's bunches and bunches that are really interesting.
I think we kind of specialize in unusual.
Yes.
Maybe
ask another question.
Underwater. What's the open source underwater glider? I want to see that.
Oh yeah, so I don't think unusual, but maybe like eye popping would be a good one. And looking back at some of the past grand prize winners of the Hackaday Prize are amazing. And one of them is this open source underwater glider, and we would like to do more research on the oceans. There's actually a huge knowledge gap in what's going on in our oceans, and we need data in order to do that. And it's very expensive to collect the data. If you think about trying to send people out in ships or boats onto the ocean to distribute sensors and then go back and collect them, it becomes a problem. And so this guy named Alex Williams looked at this and thought, there's this concept of a glider. So it's kind of like a passive method of propelling a craft forward. And think about it looking like an airplane. It's got like a fuselage, it's got wings on it. It might be about 4 feet long, the fuselage itself. And by altering the buoyancy of the glider, it can tilt the nose down. And when it starts to sink down into the water, those wings pull it forward, and then it can squeeze some water out of the ballast tanks and become buoyant again, and it'll rise to the surface and also propel itself forward. And this is a lot more efficient as far as energy is concerned than driving a propeller the entire time like you would with a ship or a boat. And so he went through and prototyped this, went through several different designs and tested it out, and published an open hardware platform that university researchers have actually built and used in order to send this thing out into a big arc pattern through very far distances over several weeks on one charge of batteries that are in there, collecting data all along the way.
Mike, I want to jump back in if I can. we've talked a little bit about controversial as far as people looking at it, but considering that we're talking about hacks of hardware, had there been any legally controversial articles that Hackaday has published?
Not generally legally controversial. I mean, we're taking back the word hack. I mean, the word hack we see as using someone using something in a way it was not intended, and not a hack as in stealing data or that sort of thing. So a lot of times we'll talk about security problems, but that's because a lot of people that are reading Hackaday are actually building electronics and hardware for a living. And so we need to look at, how is this device not as secure as it should be? What was the right way to design that? Can we, as a collective mind, as a nexus point in the hardware world, look at it and kind of educate tomorrow's engineers on how to build things with security in mind? So I don't think we've had anything that's been a legal a scrape for us. That's not really our purview.
So even things like we mentioned TiVo a little bit earlier, even things like, well, here's how you can replace the firmware on your TiVo, and TiVo is very much against that.
Well, I think that those were before my time, but I think on those hacks it was like how to put a larger hard drive in your TiVo so that you could record more time than it was originally intended for. And I guess that comes down to a philosophical question that each person can answer for themselves, which is, when you buy a piece of hardware, did you buy that hardware, or did you just buy the right to use that use the hardware and it's actually someone else's? I like to think that if I buy a piece of hardware and I want to improve upon that piece of hardware, I should be able to swap out for a larger hard drive, or change the touchpad to a mouse, or put a larger screen on it. I think people should not feel like the piece of hardware that they own ends at where the screws go into the case, and you can't go in and look at it. You should be able to take it apart, look at how it's built, look at what is being performed by that device, and decide how you as the consumer want to use that, or I guess misuse it for something it wasn't intended. One of the things I'm really looking at this week and enjoying is talking about the Amazon Dash button, which is kind of going out of service at this point. But that was one of the first really widely appreciated pieces of Internet of Things. It's basically a little looks like a thumb drive about this big that has a button on it. When you press the button, it orders dish soap or Pampers or whatever, and it's a marvel of design. And even if you're not going to use it, taking this thing apart and saying, how is it this can sit on your shelf for 5 years and the battery still works? How is it that it gets itself onto your network? How is it that they can produce it and sell it for $2, $3, $5, something like that? Being able to look at this and say, there's an engineering story here that other people should be learning from, incorporating into their own designs, taking the good ideas and proliferating them, and kind of leaving the bad ideas behind, and maybe talking about like, this wasn't the way to do something, is a big part of how we, like I said, stand on the shoulders of giants. Is we should celebrate the good things and talk responsibly about the things we don't think are so good.
So I wasn't intending to go to this, but that's a neat segue to the right to repair laws that we're seeing in some states. That fits rather neatly into this idea about, do you really own the hardware, doesn't it?
Yeah, I think that's a really particularly hairy topic. If you're not familiar with it, probably the biggest name in the right to repair issue is John Deere, the tractor dealer. They have an end user license agreement that says if you bought their tractor, let's say it was a $250,000 tractor, you're not allowed to change a bolt, a screw, to update the firmware, to do anything to that tractor. Everything has to go through a licensed dealer. And there's a lot of issues there. I think let's not go too deeply into that. But more looking at, should you be able to change the broken screen on your cell phone? Should hardware be designed so that you can get replacement parts and you can actually, have an item, let's say a cell phone, that works just as well as it did after you put the replacement in? I guess the relative amount of electronic waste for our small electronic devices is still relatively small. But if we just say it's so small we don't have to worry about it, these are things that we can throw away every year or 2 years, that's really going to come back to bite us as wider spread adoption and more electronics surround ourselves.
We're almost out of time. A couple questions that I always ask towards the end of the show, which is one is there anything we didn't talk about that you wanted to make sure our audience is aware of before we have to let you go?
Well, I think we talked about a lot of the Hackaday stuff that I'm really excited about. I mean, first of all, we've got almost 2 million people a month reading the website. You should check it out. There's something for everyone on Hackaday.com. Wow. If you're really into software, we just had a couple of great articles on like C++ 20, the new specification for C++ and what's coming into it. We talked about the V programming language, which is a new event this year. If you're a hardware person, you're going to find a ton about microcontrollers. If you're a machinist in CNC, 3D printing, you're going to find robots, machines that move, all of that stuff. Like I said before, you can find 30,000 projects on Hackaday.io. It's a great place to share your own projects. We'd love to see them there, but it's also a great place to just go and search for ideas and kind of go down the rabbit hole on finding all kinds of new things. I encourage everyone that's working on a hardware project, especially one that focuses on product development, to check out the Hackaday Prize, which closes on August 25th. That's prize.supplyframe.com. And there are still some tickets left. We sell our conference, which is the Hackaday Super Conference, November 15, 16, 17 in Pasadena, sells out every single year. So you still have another week to get a proposal in if you'd like to give a talk on hardware creation. But if you'd just like to come and hang out and explore this world where people spend 3 days soldering extra components onto the custom electronics badge that everyone gets at the conference, and going to talks about people that have designed equipment that monitors the feeding of lab rats at universities, or equipment that looks to remake the Apollo command module electronics in the home lab, or to build cell phones or commodity products. That's a really great conference. You're going to have a ton of fun. You can find that at hackaday.io/superconference.
And Pasadena is not a bad place to go. I've been there many times, and I've really enjoyed being there all the time. So, two more final questions. One is, what's your favorite text editor?
I like Nano myself. I've been Linux only since 2005, and if that's not installed, I'm always upset that I have to look up the commands on how to get out of Vi.
Okay, and yes, and your favorite scripting language?
I have a hardcore love for C. C is amazing, and I love writing and working in C for microcontrollers, but I do an amazing amount of Python scripting every single day because, things like taking a list of Hackaday.io projects and turning it into an unordered list in HTML that has the links and the titles of the projects. Like, I've written scripts that will hit that link, get the title out of the page, and then put it into that so I can just paste it in WordPress. Everything from that to like hourly cron jobs running in Python that track when writers are delivering articles so that we can do payroll.
Sure. That sounds great. So it's been great having you on. I appreciate that, we scheduled this sort of at the last minute, so I'm glad we were able to pull this show together. But very happy to have you on talking about what Hackaday is all about. And I'm probably going to subscribe now just because it sounds like a great thing for me to expand my horizons with. So like I said, I'm not much of a hardware guy, but if you have some software articles, those are also really useful for me. So that'll be great. So thanks, Mike, for coming on the show and talking to us about Hackaday.
Well, thank you so much. It's been my honor to be here, and I'm really glad you asked me to come on.
Very good. That was Mike Stitch. I think it's Stitch, something like that, close to that. Hopefully I didn't mangle his last name. Yeah. Okay. What do you think there, Jonathan?
Of course, I'm a huge fan of Hackaday. Have been for a long time. You asked what one of our favorite articles was, and I've thought about it, and I actually did a little bit of looking at the Hackaday stats on the back end, and I found one that I really did enjoy. It's from 2012. The title of the article is "Working Software-Defined Radio with a TV Tuner Card." And this is one of those stories. It's all about using hardware for something it's not designed for. So you can buy for like $5 a USB dongle that lets you tune into TV channels, which, you know, doesn't, I don't even know if that works anymore now that we've gone to all digital. But someone figured out that it's software-defined radio. And someone said, well, let's rewrite some drivers and put them on Linux so that you can tune into whatever, whatever radio frequency you want to. And so now there's this huge movement of a lot of people that are using these little $5 cards to be able to do software-defined radio, which basically means that you can take radio signals and you can say, I just want this piece of the spectrum, and you turn it into data, and then you can do all kinds of data processing with it. And that was 2012, and I think Hackaday was the first time that I ever heard about this. And it's just things like this are it's mind-blowing, and then it expands your horizon. You understand suddenly more things that are possible that you had no idea were out there.
You know, and I've heard about software-defined radio as being kind of like this amazing thing that you could basically, because really all AM and FM and sideband and all that stuff is really just, you know, ways of analyzing, you know, the ones and zeros, or the analog signals that are coming in. And so if you have the right drivers for it, you can basically do anything. And I always thought that was sort of fascinating, that area. And I know people that have done things like build, what am I thinking? The planes send out signals when they're flying through the air, and they were building these devices that would basically be analyzing these planes going by, and then send that into a central network for that stuff. So. Very cool stuff. Anyway, that's probably crazy. All right. Anyway, so we're almost done. We're out of time. So I need to wrap up the show. Coming up next week, we do have Dancer, which is a simple but powerful web application framework for Perl. Speaking of Perl once again, I appreciate that was the ad for this week as well. And also just added to the schedule is PyPI Security. So PYPI is the equivalent for Python what the CPAN is for Perl. It's basically the repository of everything, and we're going to talk to some people about the security about that, which should be kind of fun. I don't have anybody else on the schedule right now, which means I got to send out some email this weekend. I've got a flurry of email going out coming up. If you want to see who's coming up, go to twit.tv/floss. That's the homepage for this show. And if you have any suggestions, please tell the project leader or the community coordinator to email me, merlin@stonehenge.com. We have a live stream at 9:30 a.m. Pacific time on Wednesdays at live.twit.tv. You can follow us at Floss Weekly on Twitter. You can follow me at Merlin on Twitter, MERLYN. I am trying to set up a medium.com account so that the rest of us can all share and post articles, and we'll have an actual RSS feed for people to be able to subscribe to, and it'll be linked to from the show notes and stuff like that. I'm going to be at DragonCon in just a few weeks. That's Labor Day weekend. I'm giving a talk on Flutter, and I'm also giving 3 other panel talks. So I'm going to be really busy. I just got sent my schedule. It's like, oh my God, okay, I got to start preparing for that. I'm going to be at All Things Open in mid-October. That's going to be at Raleigh, North Carolina. We do have a discount code for that. If you're going to allthingsopen.org, you can type in Floss Weekly, all lowercase, and you'll get it at the cheapest rate they offer, which is really, really amazing. It's already a cheap conference, but basically it's going to be even cheaper. That's pretty much all I want to plug. I have one more message to deliver, but I'll wait till you finish your plug.
So I'll just mention you can follow me on Twitter over at JP_Bennett. And then, of course, you can find me on Hackaday. Every Friday, we run a security article, and then I occasionally get them other articles written. So be sure to keep your eyes peeled there.
Well, I'm sad to announce that, Guillermo Amaral, who was on this show many, many times over the years, he was suffering from throat cancer for the last couple of years, which is why he hasn't been on the show, because he couldn't actually even speak. He apparently lost his battle with that in the last couple of months. I don't have the details, but he was a great contributor to the show. I really appreciated his contribution, especially would have loved a show like today, which would have been all about, hardware and open hardware, and that's the kind of thing he really liked. And I'm sad to say he's gone. He lost the battle to throat cancer. So Guillermo, we miss you, and glad to have had you as a contributor, but sad to see you go. And that's all there is for today. So we're going to see you all again next week on FLOSS Weekly.